webinar, Preventing Client Attrition by Leveraging IBM Watson in the Insurance Industry. My name is Liz Herrera, and I'm the Director of Advanced Analytics with LPA. Now, before we get started, let me introduce who LPA is to those folks on the line who are not yet familiar with who we are. LPA Software Solutions is an analytics consulting firm that has been in business since 2001. We have over 500 clients across industries, including insurance, and we focus on helping our clients implement data and analytics solutions. Okay, so let's talk about our agenda for the webinar. First, we're going to talk about some insurance industry trends that we're seeing. Then we'll talk about the use of advanced analytics for insurance, followed by an accelerator that LPA has developed to assist our clients with implementing advanced analytics solutions. We will do a demonstration of that accelerator, and then we'll wrap up and take questions. All right, so first thing first, let's talk about some trends that we're seeing in the insurance industry. And what we're primarily seeing are three things that insurance carriers are looking for. The first thing is they're looking for more and actionable insight from their data, especially through digital transformation. And I think that's true, especially in these times. We have many clients who are going through digital transformations to stay competitive and relevant in the marketplace. And the use of data has become really critical in those transformations. The second thing that we're seeing is that carriers are looking for ways to deploy advanced analytics into their workflows. Most of what we're seeing is that insurance carriers may have either one or two or a team of folks who are engaged in building some either predictive or machine learning models, but they get stuck when it comes time to operationalize those models. And so we're seeing a real need for assistance in deploying assets into an operational workflow, which leads us to the third thing that we're seeing carriers look for, which are solutions that provide end-to-end capabilities and integration into their data systems and applications. So being able to ingest data, model it using machine learning, deploy that model, visualize the results, and then use the results in an end application so the folks on the front line have good information to use when they're interfacing one-on-one with customers, for example. Now let's talk specifically about advanced analytics. So what are the types of advanced analytics for insurance that we are seeing out in the field? And there are lots of different use cases that can be tackled, but the ones that we're seeing more recently have to do with customer attrition or churn, fraud detection, price optimization, as well as expedited underwriting. Now let's look at the first two. We're going to focus on these for this particular webinar. And why are we focusing on churn and fraud detection? And frankly, it's because they're costly. Client attrition is incredibly expensive. Industry numbers indicate that it can cost up to 7 times more to acquire a new customer than to retain one. So it's certainly worth the effort to try to do some client retention. From a fraud standpoint, the cost of fraud is really astronomical. Again, some industry estimates indicate that insurance fraud in the US costs over $80 billion. So with that in mind, LPA has worked with some of our insurance clients to develop an insurance accelerator that can tackle those two use cases for churn and for fraud detection. And let's talk about exactly what it is. So it's an advanced analytics solution that we built leveraging the IBM data science and AI technologies. So for the folks who are familiar with Watson, we're using Watson technology. And it's a set of assets that map insurance data to machine learning models that we've built for churn and for fraud detection. And the results can be surfaced in BI for visualization. And they can also be deployed to core systems and applications so that they can be used for frontline interaction. As I mentioned, the accelerator is built on IBM technology. So under the hood, what we're using the IBM Data Science Suite, which includes SPSS Modeler, Watson Studio, Watson Machine Learning for deployment, and then we have the ability to do some risk mitigation with our model as well to make sure that we're not biasing our results. And this is all built upon the IBM Cloud Pak for Data platform, which is the next generation or modern approach to deploying data science. All right, so let's go ahead and actually take a look at a demonstration of the Accelerator. So let me escape out of the presentation for a minute. And go over to my environment. So I'm over now in my Cloud Pak environment. This is IBM Cloud Pak, and I have my project set up that I'm going to focus specifically on this insurance project. And what I'm going to show you here, I'm not going to go very deep, just high level to explain. We have a set of assets that we've collected and built. We have data assets around historical policy information. We have historical claims information. And then we have new information that we can score as well. So we've loaded those all into a data store that we can access for modeling and for visualization. And what we've done is we've built a few different things with those data sets. One thing we've built is an auto AI model. This leverages the Watson AI technology, and I'll show you the results of that in just 1 minute. We also have deployment accelerators, so we have a mechanism to deploy directly to end applications. And we have models that we've built here. So we have our customer churn models and our claim fraud models. And then I have the workflows that we use to actually build those models. So let me walk you through those in a little more detail. So the first thing I want to show is the auto AI model. So this, again, is leveraging the Watson engine, and it essentially uses the newest algorithms that are out there to apply to your data and build out a predictive model or a machine learning model. And if I click on the results here, you'll see what I'm essentially trying to predict is customer churn. And the accuracy rate, is extremely high. If I look at a breakdown of the model, it does a very good job at predicting on the trues, the true yeses and the true nos. So its hit rate is very good. I can also look at my model information, and it tells me that it has auto-generated 21 features to use in the model. So it does hyperparameterization, data preparation, feature engineering, and then building the model. And it also gives me information about feature importance, so I can drill into what's driving the model here to help me explain why folks are canceling their policies. Okay. Now what I've done is I've actually deployed this. I clicked on the Save As button, and it's deployed now in a space that I can call from anywhere through an API. So this is the first model that we built, our AI model. I'm going to go ahead and close that. The second model that we built is a more in-depth machine learning approach using some data preparation steps that we've done. So we've done feature engineering, and we can use these multiple models in concert to get a really good result. And essentially I'm using, again, some of the newest algorithms, some boosted technologies, XGBoost, random forests, as well as decision trees, and I'm combining them to get a result. And my accuracy rating here is around 80%, roughly. So we're able to capture about 80% of the customers who are likely to cancel their policy. And I should note, in this particular example, we're looking at auto policies. All right. Now, the next thing that we did is build a similar model for fraud detection. So in this case, we used some historical claims data. We did data preparation, feature engineering, and we built a model using multiple algorithms together, ensembled, to identify those claims that were likely fraudulent. And in this case, our accuracy rating is over 90%. So we're able to capture over 90% of the fraudulent claims that are being processed. Now, we have three models. We have two churn and one fraud detection models. I've actually deployed these. And so we can call those at any point in time with new data. So we have a mechanism in place to score those models, the first of which is a Python notebook, Jupyter notebook using Python. And we basically set up a process that can write back to end databases that are surfacing applications. So something like a Guidewire, if you're using an ERP, would be an end target for the results of any of those 3 models that we've currently deployed. And so that's one mechanism for deployment that we've already packaged and built here. The next one is that we can do real-time deployment directly from our platform. We've deployed our models into a deployment space, and essentially you'll see the 3 models that we have here. I can call any one of these, again, from an edit application. It could be in real time. We can do a batch process as well. So we have the mechanism to schedule this as well, so I can have a job that's scheduled. So every day, for example, at the end of the day, we can score our models, and we can have the end results be published into a database that then is used for operational purposes. Now, we've taken the information from the models and we fed it into a dashboard. And I'm going to spend a little bit more time there to show the results. So we're going to look at the model results, the predictions for those folks who are at risk for churn and whose claims are likely fraudulent. And if you're interested in seeing more of the key drivers behind the models, you can certainly contact us. We'd be happy to do a demonstration to go into the models in more detail to review that. But let's go ahead and actually look at the results visually. So I have my dashboard here, and the first tab that I have is my churn analysis. You'll notice at the top, I have my metrics that are important to me. So I have information about the number of policies, the premium and incurred loss that we have associated with those policies, changes year over year in premiums. And then I have information about the policies that are predicted to churn. So everything you see in this view represents those policies that are at risk for attrition. And you'll notice on my map here that essentially it's showing me the counts of those folks who are likely to churn visually. And I can hone in on any one of these counties here and get some information. So for example, Carbon County in Pennsylvania is a dark blue. That's telling me that that's a hot spot for churn. And I can see how much loss associated. So we have some loss information kind of tagged to this. I can see that it's responsible for quite a bit of loss in the last 5 years for us. I can also go over and look at the county information in my table here on the right-hand side. So for Carbon County, I can see that the average loss ratio is actually pretty high. It's over 70%, so that's certainly problematic. So these folks who are likely to churn, there must be something here that's driving that information. So let's look a little bit more deeply at some of the key drivers here. So I can see that from an age perspective, we have some of the younger folks who are more at risk for churn as well. The 24 and under have a high likelihood of churning. I also might want to take a look at some of the other age brackets to see from a loss ratio standpoint where I might want to focus on. So for example, we have folks who are in the 25 to 39 age bracket who are at risk to churn, who are just under our threshold for kind of the problematic loss ratios, but there might be something there that we can recover. Maybe we need to make some adjustments. We can get people back on track and prevent their churn. Let's go ahead and look over at our heat map. So this heat map is looking at the predicted churn by marital status, as well as we're looking at our loss incurred, as well as premium changes year over year. And what I'm looking for in the heat map is where the color is darker. That's where I want to pay attention to. And what I can see here is that I have my married folks who are predicted to cancel. Their losses over the last 5 years have been fairly large, over 38 million, and their premium changes have averaged almost 32%. So that could be a key driver for why those folks might attrit. Their premiums might just be too high, so they're going to look to move on. So we can dig into the details on any one of these visualizations, and let's go ahead and do that. Let's actually drill through so I can look at a detailed report that gives me information down at the individual policy level. So now I have a detailed report, and we're looking specifically at our churn information, and I can do some filtering here. I can filter by date if I'd like to. I can select from the first of the year through today or a different time period. I can look at a specific age group. So right now we're looking at the 40 to 55 because I clicked on the heat map for this age group. What if I also looked at a specific location? So maybe I want to look at just the folks in Pennsylvania. So this is all of the individuals in Pennsylvania, and we'll look at those folks who are predicted to cancel as well. Okay, so we'll apply our filters. Now I have a nice report that shows me at the individual policy level information about the policyholders who are at risk for churn. And so from an operational standpoint, I can have someone on the front line who has access to some of this information to say, you know what, a specific individual has a high risk for churn. Let me make an offer that makes sense for them. Maybe it is a premium reduction to get them back on board. All right. Let's move back up to our dashboard. All right, let's look at the fraud analysis dashboard. So the first thing you'll notice again is at the top of the dashboard, we have our KPIs and metrics that are important to us, including the number of claims, the claim amount. And if we start over here on the left, we can see there's a breakdown of predicted fraud. Again, this is our prediction. So we can see the predicted fraud versus number of investigations. We can compare that to the rate of investigation for our predicted non-fraud. I can also see if we have any patterns and trends by employment status. And I can see that in some cases, it looks like we might have more fraud associated with certain employment statuses. In this case, there is a pattern or trend that there are more folks who are unemployed who are engaging in some fraudulent claims. And I can see those numbers in detail just to the right of that bar chart. So I can actually look at some of the detail here, the number of policies associated, the medical expenses, property loss, etc. Now, if I want to get into some high-level information or metrics on the bottom right here, I can see my total claim amount and then a breakdown of the property loss and the medical expense over time. So this is over the course of this year, beginning in January to the current time frame, and this is overlaid with the number of claims as well. So I can see patterns and trends in the claims that are being submitted, as well as the amounts. And again, this is predicted fraud. So if these claims were to be paid out, it would be pretty costly for the business. Now, the other thing that's important is to understand some of the key drivers for some of this behavior. And what we have on the bottom left here is a Sankey chart that helps us to understand some of the drivers for fraud. So, for example, we can see that there is more often than not a witness associated when folks are engaged in fraud. The car is towed. Again, this is auto policies. There tends to be a police report filed. And then there are some patterns in terms of the age groups that are engaged in fraud. Now, before I go down to a detailed report, let's look at some additional metrics for fraud. When there's a lot of data, a lot of information, we didn't want to lose anything here. So I can check my fraud cases by coverage type, and we can see that there's more fraud associated with collision claims and rental and reimbursements, and then property damage for those folks who are uninsured or underinsured. So for the other claimant. I can also, again, look at a geographic view of my fraudulent claims, and I can see that there are some patterns here. So for example, in Pennsylvania, Venango County seems to have a higher incidence of fraudulent claims. I can also see my fraud predictions by age and resident type. So I'm looking at my fraud group here, and I can see that if you're a 20 to 24-year-old renter, the likelihood of fraud is increased, right? We're seeing predicted fraud at a higher rate. And the claim amount for that group alone is $2.34 million. So if we were to pay that out, we'd be out $2 million. So that's some really good insight there. We have the predicted fraud by time period, so we can view a trend over time. Again, this is over the course of this year. And we have some information on the policy level, some information about the claim date, etc., claim amount. Now, if we want to look in more detail for the fraud information, let's go ahead and actually drill through to a detailed report. Okay, so we're just going to open up my report. And again, you'll see we have a report that gives us the policy level information. We have a prediction of fraud. We have a confidence score in the prediction, and I can see just the way that we have things sorted here, that we're highly confident that these particular claims are indeed fraudulent. So again, we can get some really good information that can be used at an operational level. You can look at groups of results, you can look at the individual results. And again, we have some filters here. I can filter by coverage type. So if I just want to look at collision, I can do that for fraud. So let's go ahead and apply that. Now this gives me a filtered list. I have 73 claims for collision that are predicted to be fraud, and it accounts for over $213,000 in the claim amount. So you could spend a good amount of time just digging into the detail. You have the high-level executive dashboard view that gives you the picture of fraud at a company level, and then we can get to the detailed report where we can see at the policy level some good information about the policyholder, the claim information as well that can be used by the folks on the front line. All right, so with that, I'm going to jump back over to our presentation and talk about how you can get started. So if you're interested in seeing the demonstration in more detail, please reach out. We'd be happy to walk through either the data science piece with machine learning models. We can walk it through those in more detail. We can dig in more to the dashboard and the detailed reports from the visualization. We'd be happy to do that. If you want to talk about your specific use cases, or you saw something that you thought was missing from the dashboard, or an important KPI or predictive outcome, we'd be happy to talk through your use cases through a visioning workshop for free, of course. And if you like what you saw and you'd like to get going with the Accelerator, we can certainly help you with a fast start to quickly deploy that in your own environment. All right, so with that, let's go ahead and take some questions. All right, first question, what has the return been on this solution? That's a really great question. So what we've seen so far, I can give you some rough numbers. I mentioned some of the accuracy on the churn model. We're certainly seeing it around or above 80% accuracy, so we can capture at least 80% of the policies that are at risk for churn. From a fraud standpoint, we're around 90% accurate. What does that mean in terms of the numbers? So what we've seen so far analyzing our client data, on the churn side, that translates to, from a premium standpoint, like roughly $50 to $60 million. Loss amount was about around 30 to 35. So loss ratio on average around 55%. but in just revenue numbers, around 60 million for the predicted churn. For fraud, the claim amount has been around 10 million in claims, and that's across both the property loss as well as medical, etc. So significant money we're talking about in terms of being able to either recover money if claims have already been paid out, or implementing this proactively, potentially reducing costs, whether it's through fraud or through the customer attrition. But good question. There is actually a real return on implementing these models in production. All right, let's go to another question. How would this work with my company's data? So also good question. The way that we have this set up, we have a data map where we can ingest your data and pump it through the models that we've already built. We can also customize them as well as the visualization. So this is really an end-to-end solution where we can just take your data and pump it through and get some results for you. So great question. We'd be happy to follow up and talk about what that would look like with your data. All right, let's take one more question. How long does it take to get started with this? Putting my technician hat on, and I always want to say it depends, but honestly, because we have the accelerator, I would anticipate that we could get started in a matter of days, finish in a matter of days to weeks. This is not months and months and months of development and integration. That's why we built the accelerator, was to actually support our clients in implementing these kinds of solutions more quickly, so we can help you get up and running very quickly within a matter of days or weeks. All right. Well, thank you for your time. We appreciate your participation in the webinar. If you have any additional questions, if I did not get to anybody, please feel free to enter in your question in the chat. We will get back to you as soon as possible, and I look forward to talking with you in the near future. Thank you and have a great day.